Okay, Assalamualaikum warahmatullahi ta'ala wabarakatuh and good day everyone. Alright, so today's asynchronous lecture, we are still in chapter 3 part 2. Okay, so I guess now my first video for today's asynchronous lecture ni adalah video kalau kat YouTube tu dah part 21 dah ni. Tak habis-habis lagi. Alright, so continuing from our synchronous lecture yang sangkut-sangkut last week, okay, we stop here, right? I ask you to submit example 9.1 to determine the local maxima or local minima, okay, using the first derivative test. Okay, remember we do the line test, okay, whether it's positive, negative, positive teka, we substitute a value, and if it is positive maksudnya the slope is more than 0 kan. Kalau more than 0 maknanya kecurunan dia tu menaik, is increasing. If negative, then it's going down, positive going up again, for example yang ni. So if the changes from positive to negative, you will have local maximum. Negative to positive, you get local minimum. Okay, so last week we have discussed this method in order to determine the local maximum or local minimum. So first thing for today's asynchronous lecture is still the same thing to determine the local maximum or local minimum, but now we are using what we call as the second derivative test. Okay, so this second derivative test says that if f double prime maknanya dua kali differentiate f double prime c more than 0, if you replace or you substitute the critical number c into its second derivative and you find out that it is greater than 0, meaning that function f has a local minimum. Dapat positif, dia adalah local minimum at c. If you get f double prime substitute with c, you get less than 0, then meaning that it has a local maximum. Okay, maksudnya using the second derivative test, first step you have to find the critical number c, find c, differentiate f prime x equals to 0 or does not exist kan. Second step, you have to find f double prime x. Third step, okay, masukkan x equals to c tadi, yang ni ke dalam f double prime x and check whether dia more f double prime c tu more than 0 or f double prime c tu adalah less than 0. If it is more than 0, meaning that we have local minimum at x equals to c, and other if we get less than 0, maksudnya kita ada local maximum at x equals to c. So now, let us repeat again the example that I asked you to submit for classwork submissions last week. Okay, so maknanya yang ni fx, or I shall write on the ni. Okay, the function is fx equals to 6x square minus with x cube. Betul ke? Yes, it's correct. So the first step, we differentiate. Yang ni kita dah buat dah pun sebelum ni. 12x minus with 3x square. Let it equals to 0. So you factor out 3. You have 4 minus with x equals to 0. So 4x. Sorry, silap kat sini. Okay, we factor out 3x kan, 3x, 4 minus with x equals to 0. So in this case we have critical numbers, you all sepatutnya dapat x equals to 0 and x equals to 4. Okay, so kalau sebelum ni you do the real number line test, but now we using the second derivative test, meaning we have to differentiate for the f double prime x, meaning that we have 12. Okay, differentiate 12x minus 3x square. So we have minus 6x. Okay, so here to test whether these two numbers, 0 and 4, okay, these two critical numbers, whether it's local maximum or local minimum, we just put in the value f prime 0, put inside, you get apa? Masukkan ke dalam 12 tolak 6, kosong, definitely is more than 0. So meaning that we know x equals to 0 is local maximum ke minimum? More than 0 local minimum. Then we put in f double prime 4. So you will get 12 minus 6 times 4, 24. So 12 tolak 24, you will get negative 12. So definitely it's less than 0. So in this case, maksudnya x equals to 4 is a local maximum. Okay. The point here is a local maximum. So maknanya kalau nak tahu value, okay, you have to find the value lah. Maknanya masukkan x sama dengan kosong ni ke dalam function fx kat sini. Okay, maknanya yang ni akan dapat kosong lah. Okay, f kosong. Okay, is a local maximum. So the value f kosong. Yang ni pula f4, masukkan value f4 ke dalam. Yang ni maknanya kira lah 6 darab dengan 4 square tolak 4 kuasa 3. Adalah value dia tu. So the value of the local maximum tu when x equals to 4 is such value. Right? Okay, so we're done with this example. Jawapan yang ni tadi 32 is equals to 32. So maknanya local maximum local, saya buat conclusion sebelum local minimum at x equals to 0 where we get f0 is 0. Local maximum at x equals to 4 where we get f4 is equals to 32. So nampak tak value tu maximum tu tinggi kan? 32, minimum tu hanyalah kosong. Alright. Okay, so now we proceed to example 10. Okay. Example 10 here, determine the local maxima or local minima of fx using both tests. Okay, so the question asks you to use both tests. Thus, determine the intervals on which fx is increasing and decreasing. Okay, saya tak nak, maybe untuk A, saya akan using the first derivative test. Untuk B, saya akan use second derivative test. Dan untuk A nanti, okay, yang using the second derivative test, saya nak suruh you all buat. Untuk B pula, yang using first derivative test, saya nak suruh you all buat. Faham tak maksud saya? Maknanya saya buat salah satu je. Then you are to complete the second method. Alright? Okay, so for fx A here, A, fx equals to 3x power of 4 minus 4x cubed kan. So we are using the first derivative test. Okay, okay, so we use first derivative test. F prime x, we will get 12x cubed minus with 12x square, right? 12x cubed minus with 12x square. So you may factor out. So critical number memang saya dah bagi kat you all ni. 12x square. So we have x minus 1 equals to 0. So here we have x equals to 0 and x equals to 1. So these are our two critical numbers. Okay, so here kalau using the first derivative test, maksudnya kita buat line garis nombor ni kan. Okay, so 0 and 1. So kita masukkan factor 12 tu tak payahlah, dia tak ada sign, dia kita tahu dah. Tu kita just ambil x square dengan x minus 1. Alright. So here so now I'm going to replace with the number to make the line test number ni line test. Real number line test. Okay, so for x less than 0, any number you may pick, katakanlah saya ambil negative 1 square, you will get positive kan. Negative 1 square. Negative 1 tolak 1 negative. So I will get here negative. In between 0 to 1, katakanlah separuh lah. 1 over 2 square is positive. 1 over 2 minus 1 is still negative. So meaning that you have negative. And then more than 1, katakanlah 2 positive, 2 minus 1 is also positive. So look at the shape. Okay, macam saya sebut, negative is going down. Again, negative is going down. and then positive is going up. So maknanya apa yang kita ada kat sini? Do we have local maximum? No, we don't have local maximum because at x equals to 0 here, the sign is changed from negative to negative. Tak ada apa-apa bentuk ni, dia selari kan? So there is no local maximum or local minimum at x equals to 0. But we have a local maximum ke minimum ni? Okay, turun dan naik. Nampak ni kat bawah kan? So meaning that local minimum at x equals to 1. Local minimum x equals to 1. So maknanya boleh gantilah value F1 sama dengan 3 tolak 4 negatif 1. At x equals to 0 tak ada. Local maximum pun tak ada. So local maximum none. Okay. And then the question also asks you to find the intervals of which fx is increasing and decreasing. Okay. Of fx is increasing or decreasing. So untuk determine whether it's increasing or decreasing, maksudnya kita tengok je lah sign kat sini. If it's negative, maknanya dia decreasing kan, negative decreasing, but it is excluding 0 kat sini. It is excluding 0. So maknanya interval of increasing, maknanya function tu at x equals to 0 dia tak masuk. Okay, kenapa jadi macam tu? Sebenarnya graph tu at x equals to 0 dia tak increase ataupun decrease, something like this. Macam tu. Okay, at that function tu sebenarnya macam ni lebih kurang. dia tak increase or decrease. Okay, so interval of increasing maknanya yang positif. So it's from excluding, okay, open bracket 1 to infinity, goes up to infinity. Interval of decreasing, okay, decreasing maknanya daripada negative infinity until 0 union exclusive of 0. So 0 buka balik up to 1. Okay, so this is the answer for interval of increasing and decreasing. Alright. Dah, saya rasa saya discuss terus lah. Tak payahlah you all submit yang ni senang sangat. Okay. So for second test, okay, if you want to use second test, maksudnya we differentiate again from f prime x to get f double prime x kan. So maknanya kat sini kita akan dapat apa? 12x cubed, we differentiate, we get 36x square minus with 24x kan. Okay, 36x square minus with 24x. So yang ni, kalau maknanya yang hitam ni, ini dawat hitam ni, dia kita guna second derivative test So f double prime kita gantikan dengan kosong into 36x square minus 24x. So you dapat apa? Kosong-kosong, you dapat kosong. Right? We get 0. And then if we replace with f double prime with 1, 36, okay, darab dengan 1 minus 24, darab dengan 1, you get apa kat sini? You get 12, right? 12 kat sini, tak ada pula, tak boleh nak tulis kat sini. Is equals to 12. Okay, 12 ni, okay, this 12 is more than 0, right? So if it is more than 0, maksudnya f at x equals to 1 ni adalah local minimum. Okay, at x equals to 1 is local minimum, whereas 0 is not more than is not positive, is not more than 0 or not less than 0 because dia 0 kan. So maknanya is inconclusive. Okay, dia bukan bukan local minimum or bukan local maximum. Okay, inconclusive, dia tak ada. Okay, it's not local minimum or local maximum. So what can we conclude? Only x equals to 1 is our local minimum. Same as what we have, we get the answer using the first derivative test. To determine the interval, we still need first derivative test. Kita tak boleh guna second derivative test untuk determine the interval of increasing or decreasing. Right, class? Okay, so now let us proceed to example B. Okay, so untuk example B here, alright, we have fx equals to x plus 2 sine x. So untuk f prime x, okay, first we need to find the critical numbers. Okay, f prime x, kita ada differentiate, we get 1 plus 2 cos x. Okay, 1 plus 2 cos x. So daripada from here, okay, we let it equals to 0. So we have cos x equals to negative half. So to determine what is x, you need to find, you may press your calculator lah, cos inverse negative half. Okay, kalau plot the graph, gambar cos ni macam tu, ni apa value kat sini dengan kat sini, cos half. Okay, so cos negative half, silap ni, dia yang negative half kat sini. Okay, so these 2 points. Okay, so if you press calculator ataupun if you ingat, it will be good kalau you ingat. Okay, it's 120 degree and 240 degree, or you can put it in radian. Maksudnya kalau dalam radian berapa 2 pi over 3, and another one is 4 pi over 3. So that is our critical numbers. Okay, critical numbers. So kalau now up to you. Okay, kita katakanlah kita nak use the second derivative test. Maksudnya we have to go on f double prime x. F double prime x, kita differentiate one more time. So we get, differentiate 1, you get 0. 2 cos x, differentiate, you will get negative 2 sine x equals to 0. Okay. Sorry, it's not equals to 0. Kita just differentiate je, bukannya make it equals to 0. So f double prime x, we differentiate 1 plus cos 2 at respect to x. So we get negative 2 sine x. Then we put in the value, okay, which is 2 pi over 3. 2 pi over 3 into the function, okay, negative 2 sine 2 pi over 3 ataupun sin 120. Okay, so if you press the calculator, negative 2 sin 2 pi over 3 sin, okay, 120 degree is positive tapi darab dengan negative 2 kat sini, then we give you less than 0. Okay, so meaning that we know now local maximum at x equals to 2 pi over 3. And then we replace f double prime x with 4 pi over 3 into 2 sine 4 pi over 3 ataupun sine 240 degree. Yang ni tekanlah calculator kalau you tak ingat. Okay, so sine 4 pi over 3 ni sine 240 darjah. If I'm not mistaken, dia akan keluar negative value, darab dengan negative 2, dia akan jadi positif. So we get more than 0. Then we can conclude that we have local minimum at x equals to 4 pi over 3. Alright? Okay. So we done using the second derivative test. However, okay, nak cari value, you may put in lah 2 pi over 3 ni ke dalam function ni. Okay. However, to determine the interval whether it's increasing or decreasing, you still need the first derivative test. Okay, so now I'm going to show you to do the real number line test untuk determine the interval of increasing or decreasing. So we have two numbers. Kita ada 2 pi over 3 dengan 4 pi over 3. Okay, and we are to replace into cos x. Senang je ni. So cos, kita carilah apa-apa nombor yang ni ataupun 120 degree, yang ni 240 degree kalau you tak familiar dengan radian. So anything less than 120, of course lah, for me I will choose 0 lah. So cos 0, dia ada interval dia, interval dia 0 to 2 pi. So you have to stop at 360 degree. So in between this, okay, so katakanlah saya ambil 60. Okay, cos 60 in the first quadrant is positive. Okay, it's positive. Okay, we put inside. Alright, so we have here positive, and then in between 120 to 240 degree. Maybe the easiest one is 180 degree lah. So cos 880 degree is, press calculator, you will get negative 1 kan. Okay, and in between 240 degree to 360, ambil lah apa-apa nombor. You may press the calculator, say cos 300. So I think you will get positive. Press calculator. Kalau dalam kelas saya boleh suruh you all try to press lah, but now no choice. Alright, so now we press the calculator, done. So now we already come out with the interval of increasing and decreasing. Yang positif tu maksudnya increase kan. So increase kat mana? Increase daripada 0 to 2 pi over 3 and 4 pi over 3 until 2 pi. And decrease is the negative kan. Negative decrease maksudnya dia adalah dari 2 pi over 3 to 4 pi over 3. And then this one also actually you may determine local maximum or local minimum tadi. Kita boleh buktikan lah sama tak dengan jawapan yang kita dapat daripada second derivative test tadi. Positif maknanya dia naik, negatif dia turun, positif naik balik. Betul tak? 2 pi over 3 is our local maximum, 4 pi over 3 is our local minimum. So for your conclusion, yang mana lagi senang? First derivative test or second derivative test? Jawab sendiri. Okay, I think of course first derivative test kan, sekali arung kita boleh guna dua-dua terus untuk determine interval dengan decide whether is local minimum or local maximum. Kalau second derivative test ni dia boleh hanya untuk determine sama ada function tu local minimum or local maximum kan. Alright, so that's all for first part of our asynchronous lecture today.